Okay, let's introduce, maybe go, because we have Ariba and Sinanu. Okay, I'm Judy. I'm in charge of organizing the book club.
I'm Abigail, radiology technologist, trying to learn all of this. I'm super, super new, so still learning.
Hi, sorry, I'm kind of in a loud place right now, so I hope you can hear me, but I'm a med student. I'm an M1, and I am really interested in machine learning. I worked at Google as a software engineer before I came to med school, and I'm excited to learn more about what everyone does.
Okay, welcome.
Hi, I'm Chima.
Oh, go ahead, sorry.
Hi, I'm Chima. I'm a tech student, Georgia Tech student, and I'm pretty much very interested. I want to learn more.
Okay.
And I'm seeing I'm having problems with my iPad camera, but anyhow, one of the radiology residents, first years at Emory. Total noob in terms of coding and Python and all the above, but would love to learn some. So.
Elmira?
Yeah, so I'm Elmira, and I'm a fifth-year radiology resident at the University of Illinois in Chicago. And I'm very interested in neuroimaging and like fMRI and signal processing. And thanks to Judy, I'm invited to this book club, and we will be learning more.
Okay. Toby?
Yeah, I'm Toby, and I'm an incoming student at UIC. I'm interested in biomedical imaging and deep learning techniques.
Okay. Okay, so I think Priyanshu is going to join soon. So how was this chapter 2? I'm curious to hear reactions. Did people get to the end, midway? How was chapter 2?
I got to the end 5 minutes ago.
Oh, okay, that's good. That's good. That's good.
Same.
Yeah?
Pretty similar. So this is sort of our hell week.
Exactly.
Which meant, yeah, a lot of stuff was due this week for me, but I woke up early and started.
Okay. Okay.
It was good. It wasn't difficult to go through. Conceptually, it was good. Like I liked there's a great textbook.
Exactly.
Yeah,
I do have to admit that it's a great textbook. It is a great textbook. I mean, even if you're an expert in machine learning, there's something to learn here.
Mm-hmm.
Okay. Abby, how was your experience? And I apologize in advance.
I got stuck like loading the data on the Google Colab because every time I put it the way the book said, it kept on telling me that there's a syntax error. So I was trying to figure out what I was doing wrong, and I don't know, I couldn't figure it out.
Okay. So I will schedule some time with you and walk through things and just make sure you're up and running. Okay.
Okay.
But please do not give up. That's the only request that I have. Toby, what did you think of the book?
Yeah, the book is super educative and super enlightening. I learned so much. Grid search, random search. I've never used those algorithms before, models before, so it was fun. It was fun for me to an extent. It was.
Okay. Do you guys want me to go through just unpack the chapter? Maybe I'll take like, and we can keep interrupting each other, and it's okay. We're still gonna keep this too close to just an hour. If we are not able to go through everything now, we'll come back again next week. I mean, we decide the pace for this, right? But this was a great chapter, and you can let me know if the pace is bad, and I'll just do this, but in future, I'm going to have someone else lead the chapter discussion, okay? I'm just setting up this for this, okay?
Sounds good.
Okay?
Yeah.
No? Okay, good. So, I thought I agree, this is a fantastic book, and I'm going to derail a little bit, but don't worry about the good thing about recording is you can always go back and see, right? So, you know, I may have to refresh just to make sure that I'm logged in. No, it's good. So this was an end-to-end machine learning project, and by the time we're done with the chapters, we're gonna be good. What I want you to mark is this working with real data, okay? And because these data sets are going to be important, right? Because practice makes perfect in this area. Okay, so just mark this because you're gonna go back, and I actually spent some time looking at that. So you can see that I have, like, I really like the bank marketing data set. And, and you know, the classification goal is to predict if the client will subscribe, yes or no, to a term deposit, right? So now I have this data set that I can look at. And I also spent some time on the AWS, which is the Amazon Web Services data set. And I liked the taxi and limousine commission trip record, you know, which you see now we start to have interesting data sets that you can work on. But so that was that first chapter. And obviously the task here was to use the 1990 California census, okay? And, you know, to say, you know, can we use this census data to build a model of housing prices in the state, okay? And you know what I liked about this was the so what? Why are you building this model for, you know, for pricing in the state, right? And you know, it describes a little bit that the data includes the population, the median income, the median housing price for each block in California. And a group block typically has a population of 600 to 300 people, and we'll call them districts. So what I liked here was this, your machine learning project checklist. And I mean, I think that's super important because it's going to be guiding you through everything. I would put this as somewhere where you're coming close, and just every time you're approaching a machine learning project, to be honest, I really encourage you to walk through this list as we go along, because I think even for me it was such an opportune time. And this is Appendix B, okay? And so, you know, and this is how the book went, right? You frame the problem, get the data, explore the data, prepare the data, explore many different models. Remember, this is the no free lunch theorem, right? You never know the model that works best. And so you shortlist the best one, you fine tune them, you present your solution, and you launch, monitor, and tailor your solution. So as we go through cases, and hopefully as we start to do other projects, to gain expertise, that you're going to use this project checklist, and this is how we'll be discussing our performance of projects. So so this is a gold mine for that. And so they start by framing the project, and you know, obviously we're trying to predict the housing, right? To build a model of housing prices in the state. But why do you need to build a model of housing prices, right? Because you could say that, well, you know, your boss is going to use this algorithm to determine, is this an area worth investing or not? So that becomes a problem that all of us can understand, right? But what they say here is that it's components, right? You're just looking at district pricing, but someone else may look at something else, and all these things get into this investment analysis to a decision making that decides whether you should invest in an area or not. And so this sequence of data processing components is called a data pipeline. Okay, so this is the first time we introduced this. Please feel free to introduce me anyway. I'm just trying to set up the talk for discussion, okay? And so, and these pipelines, you'll hear even on our lab meeting, we're always talking about pipelines, you know? And this is what we're meaning, right? You're setting yourself to figure out what data processing components you're going to work on. What I liked about this was how much time you spent cleaning the data and gaining insights from the data. You know, the machine learning component really was like 10%. You know, it's this, which is why I really encourage us to use, almost like print that appendix or put it somewhere. When you're approaching a new machine learning problem, just walk through it, and I do believe that we all get better. And so you have to ask your boss what the current solution is. And so the boss here says that the housing prices are currently estimated manually by experts. A team gathers up-to-date information about a district, and when they cannot get the median housing, they estimate it through complex rule. And you know that they've figured that the estimates are usually off more than 20%. This is important if you're thinking about this, because this is what is going to be your ground truth, right? Is your model better? Or does it perform the same, but because it's such a manual process that people like, people like to use it. So when we looked at this, right, we is this a supervised and supervised or reinforcement learning, right? There were no rewards being given at every point, so it's not reinforcement learning. So this is growing in from chapter 1. And supervised, we want figuring out new categories, but we always had inputs and outputs, right? We had the housing prices and the district. And so this is why we say that this is a typical learning task, right? And if you go back to chapter 1, you can see that this is a regression task because we are predicting a value, and because we're using multiple features to make a prediction. For example, the district's population and the median income. That's why it was a multiple regression problem. And because we're only trying to predict one single value for the house in the district, then it's a univariate regression problem. Okay, so this sets the sort of like the chapter 1 information of trying to figure out what type of machine learning we want to do. And because the data is small enough to fit in memory, so plain batch learning was fine. If you remember, online learning were things like you have these big stocks that you need to keep updating, and that was not the case for here. Any questions or comments up to that point? Okay. So the next thing that was introduced here are these performance measures. Does anyone want to walk through the RMSE and and the MAE? What they understood about those two?
We just did this last time. So the pretty much RMSE, or root mean square error, is sort of like if you have, for each of your examples, you sort of find the difference between your predicted value, as in the value your algorithm put out as, this is what I think is the housing price value. And you find the difference between those two. And for each example, you square it and then take sort of the mean of that, and you take the mean, you take the average squared, sum squared of that, and then find the root of that value.
Okay. So don't be intimidated by math. Chima, Toby, they probably and Priyansh need to know the math, but we don't. We just need to know what's the metric and what it represents, right? So for example, if you say that, and we look at it actually in the end, right? So if you say that the RMSE, so for example, let's say the first district, if your system predicts that the median housing price in the first district is 158,400, and where is the true value? The true value was 156,400. Then you have an error of 2,000, which just shows you the deviation from the truth. So you have the actual value and the predicted value. And so the way it's calculated is to allow us to be able to say, you want to narrow the RMSE. That's the gist of it, right? Because you want to make sure that you're not too wide. And if you, Toby, would know this, and Chima may know this, because the task that I give new students coming to the lab is usually that if you ever present an RMSE, what else do you need to talk about? Toby, Saptashi talks about this all the time. When you present an RMSE, what other things does he want you to present about the RMSE?
Okay, the MAP and the
Yeah.
MAE.
Yeah, but the confidence interval, right?
Yes.
Right, you've heard him talk about that every time you talk about this RMSEs, you have to talk about the confidence interval, okay, and the standard deviation. So what's the MAE? Mean absolute error. It's still a distance, right? It's used to measure, make sure that we're not leaving anyone out here. Priyanshu, could you explain what's MAE and RMSE and the difference, and when should you use one versus another? Or Ariba?
Is Ariba proceeding?
Priyanshu is proceeding now.
Yeah. So, okay. So RMSE and MAE, I mean, both of the metric to calculate the errors, but when you are calculating MAE, you are calculating the absolute error and you are not penalizing for the large errors. So if you have large errors in your system, you should use the RMSE values. And if you are going for the interpretation point of view, you should go with the mean absolute error.
Okay. Okay. So we saw that if you have many outliers in your system, then you should use the MAE, right? But if you have, because RMSE is very sensitive to outliers, but then, you know, I think, I don't know that, I don't want to spend too much time on the math. I just want to say that at this point, you just have to know that there's a way to figure out if how bad your system is performing, and you use the RMSE and the MAE. If anyone has a much better, interesting description without the math, I would be happy to hear it.
And so, Judy, I just want to say that this box over here.
Yes.
So this was the peak of this chapter.
Okay.
It was well written and it was so to the point. It's like describing, because I think although it looks like math, but it's a concept, and I think we all should realize that. And so it is not intimidating
So,
at
okay,
all.
do you want to go through the book?
If you just look at should I take control?
Yes, absolutely.
Oh no, like I could have like.
Oh, okay. Took my screen. Yes, I can do that.
I just wanted to like point out that how he was explaining that, and like how.
Do you want to request control?
Yeah.
I still don't see the request.
Yeah. Never mind. So let me just.
Yeah, I'll highlight for you.
Yeah. So that RMSE equation there. So it is basically this is just nothing. It's that. Let's just start from that x I. Like no in the middle, the like, yeah, that one. So that's and so that is that is our data and all the attributes of our data. If you just scroll down, there's so they show that. So for example, we have like the income metrics, we have all these like different attributes that we have in our data, and those are all in exactly there, or they have name for each index, so that one is like one district, and it has multiple values, and so there's this H that is actually the meat of our algorithm. So that is a function, a mathematical function that is figuring out how they can produce, how they can change, like tweak these data with that H to come up with a value, and that value. So they could have like easily. I thought about like why he chose to present RMSE this way. Was actually, I think it's bright because he used H times like X. The I index instead of just using Y hat I that we usually like see, and I think that's like actually a good way to use it to highlight the value of H. That H is what our system is trying to figure out like what to do, and then this product will be an estimated value, like what our model estimates, and that YI is what our actual value is. And then obviously, so RMSE has a definition. This is like a square of our predicted value and our like system, and then we will get the mean of that, and then we're gonna get the square root of that. And so it's just so beautifully described here. So I was so excited. I just wanted to, sorry to interrupt.
No, this is amazing. I wasn't sure if it's going to put off people, but I actually had the same, because I think one thing you can do is just write this and write like this data just on a paper, So M was the number of people. For example, if you're evaluating 2,000 districts, M is 2,000, right? So the number of count, and you know that this is sum, right? And then this, you're right, this was our data, and I actually understood it better by just looking at the example that he gave here. And all this, right, all this computer stuff is math. So you have to figure out these matrices. So that the matrix and calculations are very important for AI and computer science, right? And then the Y being the prediction, and H being the algorithm and what we're building. I thought it was fantastic. So thanks for making us bold enough to review this math without intimidation. Okay, and so you can see the mean absolute error, and if you compare it with the other one, it's that this doesn't have the square root, right? If you compare these two formulas, is that one doesn't have the square root.
Actually, now that I have some computer geeks here, let me just ask something about these two and why the square root is more at risk of is more affected by outliers than the MA, because although on that one on that one we're squaring, but we take the square root. So whatever effect that outlier is having should be then square, like the root of it will be calculated. So how come the absolute value is different? Because everything else is the same. I just don't understand this part of it.
Yeah. So I'm not the math people, but I know we have more here. I only said that because it just has a higher weight for larger errors, but I'm curious to hear what other people think.
I mean, I also don't know exactly the reason, but my understanding is that it doesn't matter if you put the square root or not, because we have another metric as mean squared error. So I guess it's just the convenient to put the lower weight. If you are square rooting anything, your numbers will automatically decrease. So my understanding is that it's just a way of presenting the thing. We can also present the mean squared error as well instead of root mean squared error, because they both will represent the same thing.
Yeah, so MSC instead of RMSC, right?
Yeah.
So why don't we put this as something one of us can go and research on and make like a 2-minute or 3-minute presentation next time, right? On this performance metric, okay?
That's a good question. Like, we never thought of that.
Yeah. Okay. So are we okay moving on to the assumptions? Okay. So this was about the data. So the way I do, I really did this, and I'm just gonna, I mean, if people are able to run the code, that's fine. What I did, Abby, was just go to the GitHub link that's linked there, and I know Elmira had also pointed about this as the result. So if you click on this get data, this GitHub link, and you go to, this is the GitHub. I just downloaded the code as a zip file. Now you can clone it and do anything. So just downloaded the code, put it in a folder in my laptop, and then I just zoomed into, like, change it directory to that folder, as you can see here, and now started Jupyter Notebook here. So I didn't do all those other steps, but that's just because maybe I know what works for me. But now I can go into my code here, and you can see that I can go back to, like, go home, and you can see my folder here, and you can see the notebooks, right? So I'm not spending too much time writing the code or doing anything else. And this is the setup that I'll have for you, Abby. Okay, guys. And the thing about this is, if you see a problem, right, like, what we'll have like a good presentation next time from one of us. I'm not going to pick on someone, but the person who decides can tell us at the end of the call. Then we'll have like a good presentation on performance measures, right? And then now you know, we could even have just something like a simple 2-minute video of how, or if you find the resource somewhere else, of how to sort of get your notebook set up, because it's easy. I don't have to worry too much. And I had to fix a few things, but I know people use different environments like the virtual end, and if someone could just do like a quick summary, or even, but then one of the things that you should be having is a blog post, okay? And the reason for that is if you've had to search for something, then someone else may search for it and improves your profile. I personally like using Fast Pages. It's something made by Fast AI. It's really easy. It's GitHub based, and you can just put Word documents on it, and it just becomes your blog post. So I would, and it just requires your GitHub. It's really easy to get started, and it takes Jupyter notebooks very well. So I really encourage people to do that, okay? So I'm just going to go ahead with I'll skip, are there sort of comments about getting the data and the environment and suggestions, best practices?
I have one comment. The way I did it, I just opened up his GitHub and then opened that chapter 2 notebook. Like if you just so this is his GitHub, yeah. So just open that. So it gives you an option of open that one in a Google Colab. Google Colab is actually really easy. You don't have to like set up anything. You will just have this one and bring up your own Google Colab. And what I did, I just created a Google account, just playing for just machine learning. And then, so I'll have like 15 gigabytes of free space. And then you are able to mount your Google Drive associated with that Google account. So you can just load everything like on over cloud, and you don't have to like use your computer, or like you don't even like, so the Google Colab, like Kaggle kernels, and like everything, they're using like Jupyter Notebook, like the concept is the same, whichever you feel like. But I think Google Colab for this one works really well, because you have the option of opening his, like the author's notebook in Google Colab, and then having a parallel one on the other side, and just like copy paste the parts of the code and like see if that works. And I check at least like for the half of the 1/3 of the first part of the chapter, I just did that, and everything works there. So it's something that you don't have to set up anything. Like you basically can just do all the computing on the cloud.
Okay. Yes, Abby? You're muted.
Oh, sorry. I tried to do the same. Like I did get to this part where you download everything from the Google Colab, and then I opened another notebook to enter the codes, and then I still got the syntax errors. You see the ones that you have right there?
Yes.
So I was like, am I doing this right, or what happened? Yeah.
So let's talk about this, right? I use Google a lot in my coding, okay? I'm not ashamed of it. I use a lot. So when I get this error, I know what the error is, but I go back and put on Google and see what does this say. And Stack Overflow is usually pretty good with the errors, right? So I have tried import this or import this, but I have this error. And you can see that sometimes this is import URL lib.request, and sometimes it's because it's not installed, right? So and one thing, especially if you haven't, I think they have good tutorials for Google Colab. I think so. So I don't know which one is good, but we should search for like a good Google Colab tutorial for people, because you're right, it's much easier to do this on the cloud. And so if you find has no attribute request, and I saw that Stack Overflow said that I need to import this in a different way, I could just come and copy paste and see to unselect a line just means you have to put a hash, right? And I could do that again. I just entered and it ran, and then I could try again, and you can see it's fetching the data.
Okay.
Yeah. So the only thing I did is I rely a lot, and you're gonna get good at this, is how to look for code and help online, right?
Okay.
Yeah, so that's all. It's just that this requires this to be URL lib.request. I would know that, and sometimes you don't know why it doesn't run. Okay.
All right, I'll try that again.
Okay, awesome. So I think let's say that our de facto will be Google Colab, okay? For working through this book. Okay, so I'm not going to spend too much time on that, but we're gonna start going through the code here, okay? And so this may be a good time if you've not learned Python, but I don't know that you should be so overwhelmed that you haven't learned it to understand sort of like Python. And one thing that at the end of this book chapter, if you could get good at, is reading code, okay? Because reading code helps you figure out something. And then one of the assignments I'm going to give us is go back through this chapter again and come up with your master template of Jupyter Notebook commands, right? So you're saying, okay, when I get data, I'm going to download the data, right? So one thing that this is just that to use any of these folders, you have to import them into the notebook, okay? So you can research this, what they are, and then these are variables. So you're just specifying that the data you're going to download is in this GitHub repo, and this is the path. And if you're like, man, what does that mean? You could go back and see, this is the GitHub repo, it's in the master. And if I went, let me go back to his page again. I just want to get out of my Collab there, or do I have it? Okay. So if you're like, and you're gonna get to love GitHub because you can explore, right? If I go here, this is a good repo because I can see data sets, right? So I can go in here and I can see housing, which is what we were working on, right? So I know that even if I look at this code, that I can go in here and I hope this is the correct one, yeah. And I can go in here and see that this pathway is just trying to tell the computer where it's going to go, okay? And this, what I want to talk about, this is Python functions, right? They're very well used. I think he uses them amazingly in this book. This is a fetch housing data function. And when you do anything that starts with a def is a function, you can decide what you're going to pass it. So you can see the housing URL is this housing URL, and the housing path where you want to save this data set is here, right? And OS, this is just make directory, housing path. If it exists, do nothing, don't throw an error. And then, create this, this is the path, and this where you're going to save your zipped folder. And then, so you're using this URL lib, which was what was causing an error previously, which is just a function from here to fetch data. And then you're going to open the data set and extract the data set because it's zipped, and then you close the extraction. So you can imagine if I was doing my master template, I would make this very generic so that every time I have to download another data set or import another data set, I'll just come back, or I'll just say import data set. So sometimes you can download it in your folder, sometimes it can be in the Google Drive, sometimes it can be in the, you're downloading it from a repository like this, okay? Please feel free to jump in between. So now to call a function, all you have to do is pass the name of the function and put the brackets, right? So fetch housing data brackets, and then it's going to create a data set housing directory in your workspace, downloads the file and extracts the CSV into this folder. Okay, I'm not going to spend too much time because we want to just go through the whole system of the book. And then this is how to read Pandas. Pandas is very important. If you're going to watch videos or tutorials about anything, I'd say you should read about Pandas. You're going to load your housing data, you have the path, and you're completing the path and saying read CSV. So I usually don't import my data this way, but I agree that it's a much cleaner way, because I usually just say data is equals pd.read CSV, and this is the folder, you know. But I think this is good, because then you can just like, I mean, I think it's much better. Okay, so yes, someone wants to say something?
Yeah, I wanted to interrupt. The thing is, while you're working with other data set, most of the time you will find that some of the functions are repeated. Just you need to change the data set name or some other variables. So my suggestion is, or the way I do is, I just implement a util class and keeps on modifying that class. That would make it a generic, and it would be useful for all the other data set or all the other works you are going to do, like extracting reading CSV, or making a data frame, or extracting the URLs. There are some functions which is going to be repeated most of the time. So it would be better if you just implement your own class rather than focusing on the book or other implementation. It's good to take the reference, but it would be good if we have our own implementation and then using that class wherever we require to proceed.
Okay.
So
are you gonna do
that
that for us, Priyanshu?
I can, but it can take some time for me. So
Okay.
it's just the thing that one should have their own utilities implemented,
Yes.
because someone like I do the way, it may not be preferable for others. Like I just make a class, then initialize everything in the constructor, and then keep on adding methods to it, so that each time if something new comes, my class is updated and I'm just going to use that part. So
Toby, you want to say
that's
something
the solution.
on the beach there?
No, I was trying to, what Priyanshu was saying, I totally understand what you're saying. So I was just like nodding in approval.
Okay. So this is important. You have to write some classes, but we are a team, so we can keep sharing, what people come up with, right? So ultimately you'll have this master thing that you can just load a new machine learning project and be done with it. Yes, Elmina?
Yeah, I just want to add so you guys are so on top of it, but I just want to add like a little explanation for the ones who are not familiar with the classes and functions and stuff. So imagine Python is like a book. And so there are so many chapters. Yes, your whatever platform you're working on is using Python, but not all the chapters of that book is loaded. But for example, like chapter 1 is about dealing with like CSV files, or like chapter 2 is about like dealing with your like creating folders, and like you're basically dealing with your file system of your computers. And in order to use those functions in those chapters, in those information, you need to like import every chapter that you need. So for example, import OS here is operating system. So basically, if you use that, I think I can get control now.
Okay, try. Oh yeah.
All right. So I think so you see my all right.
Yes.
So here import OS, it's basically saying that so import from Python, just go and find this chapter and bring it back, because I'm going to use it over here, because I'm going to make some directories. You see here, it's so that's that. So the same thing for the rest of them. And then you will see that after we import them, if you don't import any of them, if you run this code, you're going to get, oh, this hasn't been defined, because they don't know what we are referring to. So these are our references. And then after we do those, so imagine in each chapter, there are classes. Classes are basically a category of like, let's say, a couple of paragraphs of code. And in each those classes, we will have we can define multiple functions. And those functions are named as methods of that class. For example, so here we have OS here, the ones that we imported already. And then there's this dot function. You will see it a lot of times. So dot path join, this is a method for this OS. So this needs to be imported for this to be functional, basically. And then the whole thing is, so just this, you'll go and like Google Google what the class is, if you're not familiar, obviously, what the class is, what the function is, but just have those in mind. So, but just read it, as Judy said. I want to like emphasize how important reading the code is, because sometimes so writing all these codes from scratch, probably it's very time consuming, and probably it takes lots of time. But reading code and making sense of that code is probably what the non-computer scientist people do, I guess.
Yeah, but also remember, we're going to start doing Kaggle challenges, right? And if we're doing Kaggle challenges, I see, is that a big, like, yes? Good. So if you're doing Kaggle challenges, it requires you to read other people's notebooks, right? A lot, to see what they did, why they're getting better results. So if you cannot read code, then you're paralyzed, right? Because you really cannot understand it. So I think it's a skill that gets better. I really like, actually, like Mira, you just really wrap this around for people, so that when you're lost, you'll be like, oh, what's this OS? So you can just type OS Python, and you can see some examples, you know, and then you can think about, okay, so I can join, I can get this os.path or something like that. I'm sorry, guys, if this is too basic, but we need to come up from a good base for us to go up, okay? I see Toby is sleeping there in the beach, but so next thing is this pandas structures, right? And I always start with head. Head is just saying, you know, show me the top 5 rows. And if you want to show 10 rows, you just say head, open brackets 10, okay? And you can see, we see the first rows, and I can go back now to my code here. And what I do, and when I started programming, really there was never Jupyter notebooks, but we should take advantage of this a lot, because you can see that I had a problem with my installation, and I required to install sci-kit learn, but that was the error that I was getting. And you know, we've gone through this where we're getting the data, and we are running the data, and we are loading the data for the CSV, and now we are showing the head, right? And it shows your longitude, latitude, median housing median age, total rooms, total bedrooms, population, households, median income, median house value, and the ocean proximity. Okay, this is just saying, show me the data. It shows you that the data was loaded correctly. What I liked about this a lot was this info method, which honestly I don't use, but I really liked how they used it here. Because when they looked here, when you say info, it showed all the rows, all the columns in your notebook, right? And what even was important was that it showed, you know, this data frame, and there are many ways you can find the size of a data frame. So to add a new column here, and I encourage you to keep doing this, you know, don't be afraid of like trying new code or anything. You can see that in this, because I've changed housing though, that's why that may not be very accurate, because I haven't started by kernel, but that shape can give you the number of rows that you can look at. But if you look here, you'll see that there are 2640 entries, right? But how did they use this data? They looked at, oh, what rows do not have 2640? And all of a sudden, the total bedrooms, which shows that there's some data that are missing. So imagine with one command, now you can see, man, all this data is not available right now, right? And then they looked at the data type, and these are numbers, except this one, which is an object, but because we loaded the CSV file, it's a text object, right? And so if you look at sort of, their code is super well organized, really, because the next thing that you should ask yourself is, oh, I wonder what's in this object, right? So they use another pandas property, which is a method, which is value count, which just says, you know, show me all the categories in this ocean proximity. So to call a column, you use housing, ocean proximity, value counts. So that's how you use this. Really, you can just write this in your master notebook, because that's what you're gonna use. So if I say, show me the values for a different row, you just have to change this. And I just wanna emphasize on a few Collab tricks, which is to say, for example, which is the tab function, right? So right now I didn't complete that, but I typed tab, and now I can say, oh yeah, I'm interested in housing, and if I want a different column, I can just start latitude, and you can see that it autofills it, and that helps you move quickly. So you take advantage of that. And so if you look at value counts, now you see that there are people in the island, near the bay, near the ocean, and now we have enough. And then for numeric values, right? So this is basics of data. You have numeric values, you have categorical values, and you can see that to get a summary of everything just at a go, they use this function of describe. And all of a sudden, we have all our numeric categories, right? So we don't expect the ocean proximity to be here. And we have how many values are there, what's the mean, what's the standard deviation, what's the minimum and the maximum, and the 25th percentile, 50th, and 75th percentile. So if I go back to the book, you can see that they use this describe field to figure out specifically when they come here and say the 25, 50, and 75% rows shows the corresponding percentiles. And a percentile indicates the value below which a given percentage of the observations in a group of observations fall. For example, 25% of the districts have a median age lower than 18, while 50% have a median age of lower than 29, and 75% have a median age of lower than 37. Okay? Can I move on? Any questions? So the next thing that I liked about this code was so just a recap. Sorry, I'm gonna keep repeating. We get the data, we load the data, we see the data. Head is just to show us, okay, this data is well loaded. We use this info, which is like a powerful command to show me, man, show me how what are the fields. You look through the data, see what's missing, see the data types, and start to explore what the data types are, and use the describe to evaluate your numeric values. And so the next super amazing thing they did was this, where you just do housing.hist, which is just to say, I'm going to show histograms, bin everything into 50s, and this is the size of the plot, and save these figures plots, and then show the figure. And I mean, they spent a lot of time, and I kept coming back here because this shows you a lot of your data. You know, you're going to say, okay, these households, you know, I'm seeing that, you know, there's a tail here, this is the distribution. And one of the things they notice, which you should notice yourself, is that the 0, 2, 4, 6, that would be very strange for median income, right? Who makes 2? You know, like, what's that, right? And so they come back and say, you go back to the data and you start to figure out, oh, this is in thousands, right? And so that helps you understand what, you know, because these patterns, you take so long to look at them. And so I really like the part for the histogram, and he explains a lot why he chooses that. And I love this. I mean, I'm going to be using this. It's going to go to my master thing, okay? And so you can see some of the observations. Then for, like I said, the median income. So the numbers are tens of thousands. So 3 actually means around 30,000. And then the other thing that he observed here is the median house value, which I think should be here. And you can see that it's capped at 5,000. So if you're going to build a model that says that you're using it for estimation of housing in a place that the price, the median house is million, then you know your model will not work, right? We talked about those things, that your training data must be representative of the reality, you know? So they start to look at also the maximum, like what's the maximum value? So that was something else. And so you may have to either go back and collect proper labels or remove anything if it predicts above 500,000, because you don't have those values. And then, so obviously these attributes have very different scales. Some are in thousands, right? Some are in ones. We didn't have anything, and we have this in hundreds. So that's important because machine learning likes consistency. And then this tailing, which is just the distribution, that they extend much further to the right of the median more than the left, okay? Any unpacking before we jump to test sets? Am I just teaching you guys stuff that you know? Yes, okay, but I'll keep going. So there was a lot of discussion here in the test set. And so this data snooping bias is that he argues that the authors argue that when you look at the data set, it's so easy to figure out what the pattern, and that makes you say, I'm going to build this model. So you should really not even look at the data set. You should just, we spend quite some time here looking at the data set. I'm just going to go, and I think this may be I think you remember we said you always have to have a training set and a test data set. But this is super, super important. And so this section of the chapter describes how to create a data set. And they say you could just say I'm going to create my function, and what I want to show you is sometimes I don't understand what the code does. And you can see, like, I saw this and I was like, oh, shuffle index, I know this is NP, so it's numpy because we imported it here. And then there's this method, random permutation. What does that mean, right? So all I do is I create a new cell, and I'm like, and I go to Google and they say, oh, this function randomly permutes a sequence or returns a permuted range. And now all of a sudden I run it and I can change things and see, oh, it's just randomly generating things. So that kind of helps me. I do this a lot in my coding, and here we have, and what they're trying to say is that they're going to use this randomness to generate, to create an index, which is just like an ID for the data set that is going to get used. Then he goes on and say, but we could use this library which will have a unique identifier, because the challenge that he was trying to solve and the point that was being spent to discuss here is that to say, look, if I have to reload the data or I have to restart the data, right? If you're always randomly generating things, then you're going to get into trouble, because what was in your test set previously or your training set may now be in the test set. So your model is going to overfit. So how do we get to a point where we can? So he spends some time, I'm not going to, because I think finally the point was this, that it's so random. And I mean, I'm happy for anyone else to unpack this section. But what ended up happening is that he said, look, this is me using this library, which creates this identifier and a hash function, and then I put in the hash, and I said that I want 20% to be of the text. And so you can see that what happens here is that you get a housing with ID, and you reset the index. So to show this example, what I did here is I put housing with ID head. You can see the index is 0 and 1. And now when we reset the index, which is housing.ahead, the index is gone. Okay. And so this, we create an index when we reset this. So this is the original one, so it should be the other way around. And now we have an index because this is housing with ID. And so now he comes in and says, I'm going to create this ID column, which you can see here. And I'm going to say, gee, latitude and longitude never really change in my data set, right? So I'm going to create an ID with this value and multiply them and create this test. And so now all of a sudden you have this data. And so what ultimately he goes on to say is that in the sci-kit LAN model, we have this function, right? Train, test, split. And this is all you have to do to create your test set. And it's going to be consistent in your data set. Any thoughts about that? That's all this code is just to show you that this is random. You need a more fixed way of predicting this, okay? So, and then, now remember we're saying that we want to predict the median housing price, right? And we think, okay, median income is important for this. So I found myself going back to this list, and I think it's not unreasonable to keep going back to it. So we have this median income. We know that these values are in thousands, okay? And we know that these values are in thousands. And so let me make sure that I'm going through everything here. Okay, so what he brings, suppose you started with experts who told you that the median income is a very important attribute to predict median housing prices. Now you want to unpack this, right? So what they do is that if you have to feed every single number, then I think you've had this in the lab meetings where we say the model, there's just too many very wide dimensionality, right? We have to cluster things back together to make sure that the prediction works. So what they do now is use this function, which I'd never used before, which is pd.cat, that creates categories. And we noticed that, you know, our income, we're going to create categories, because if you look at the people who had the highest levels of income, it's around up to 6, right? But this is our biggest data, and you don't want too many outliers. So they create a category, and now if you look at the value counts, you can see they name the labels as 1, 2, 3, 4, 5, you know. So I know that people who have, you know, 0 up to 0.5, you know, incomes fall 1, 2, 3, so 1, 2, 3, 4, 5, and these are the category levels. And you can see this is the representation now of the final people. So then, and this is going to be sort of my last thing on here, maybe up to the discovery. I would like to get up to the data visualization and maybe stop there. And so if you look at these categories, if we gave them equal importance in everything, our model would be wrong, right? Because you know that most people are in this space, right? And this space, right? So if we gave this one the same weighting, then we'll be in trouble. And so that's when they bring another thing called the stratified shuttle split. Okay, and the chapter goes through a lot of code of how you can write your own code to get this stratification. So if you look at this function when it comes here and looks at the income categories, and you look at the original categories, you'll see that it split the test set into the same proportion, right? So this was 0.03 and this is 0.03, so that you're not having many people represented in one category. And they talk about this where they show all the things you could have done. And this is the overall category. This is when you use stratified. This is when you have this random generation of the sample size. And if you have random errors, what are the error rates for the proportions? Okay. And so after that, what you do is that if you have now a new category that's, you know, in this, now we've transformed this value as a category, then what you do is drop that column, so that you're not duplicating it, because now you have a much better role. Before we move on to all these things, what I liked a lot about this was, before you start to creating your test set, is that you should copy, no, this is fine, because this is the test set that we are never going to look at till we are ready to figure out. And so if you look here now, you can copy your data frame. I like this because you've done so much work on it. You don't want to keep working off the previous one. And I'd never done this actually, but this is a scatter plot. And I had to read a little bit about this, and it just showed that this is a bad plot, because what does it tell you? Nothing. But if you add this alpha, and you can see what I go doing with my code, I keep adding alpha, because alpha n, which is a number between 0 and 1, specifies the transparency of each histogram. So a lower value of n represents in a more transparent histogram. And now I know that if I change this alpha.0.1 or 0.2, then it becomes much more clear, right? And then what they do then is use this CMAP, plot get CMAP, and now it brings color into the function, you know? And then it also brings that this weighting, that you can see that many of these patients who are in the red and green live along the coastal line, right? And then he goes on and gets all this code is just to download a base map of California, and then puts the map there, and bam, now we have this data set that we can see, oh, where do people live least? You know, where is the another belt that we see, and where are the most people located, okay? And so I'm going to end this and just leave time for questions here, where I look at these correlations, right? Correlations so we've gone through all that. If you look at correlations, it just shows you what variables are related to each other. So I'd never used this honestly, but I loved it, because you're trying to figure out what are features of importance, right? And so you create this correlation matrix, and then it says, show me this, what's correlated to the median house value, which is the thing that we want to predict, right? And now we have, obviously, a median house value has a correlation to 1, right? It's the same variable. And then we use this Pearson's coefficient, the R. And when things are in the negative, it means they're negatively correlated. When something is going up, the other one goes down. And when they're positive, this is positive correlation. So we can see here clearly that median income is an important factor for median house value. And when things are close to 0, it means there's no relationship, right? So what they do is go in and draw these curves, right? And they do them in a really interesting thing by using this function, which I didn't know about, from Pandas, called scatter metrics. And it just shows all these things, and the way they picked these 4 variables, median house value, median income, total rooms, and housing median age, is by looking at this, what seem to be more important as features, right? And so you can see some of this like don't make sense, but maybe you can say, oh, maybe there's something there, but this is the median house value, so maybe there's something here with income. The other plots really don't make much sense, and so they come back specifically to this plot for the median income and the median house value, and start to say, look, we already know that there's a cap for the median house value at 500,000, but there also seems to be another line here and another line here. And so, but then you look at the correlation and you can see it's strong because you can see an upward trend and the points are not too scattered everywhere. And so that is where we move on to this experimenting with attribute combinations. And here what they do is that you start to ask yourself, and this is the domain expertise where you're like, what if you said, I want to know how many are rooms per household, right? So these are now new features that you're generating. And what if I said, I want to figure out, is bedrooms per room important, or is population per household important? And now all of a sudden, you create these new variables by calculating them. And these are simple calculations. And then you repeat your correlation. And now you see, rooms per household has higher importance than total rooms. And, bedrooms per room is on the negative side, is more important than the total bedrooms. So now you have these new features that you can release, and you move back to the point for preparing the data for machine learning. So I just want to stop there and hear what people's reactions are. Was it helpful? What other sort of comments people have, and we can start off with prepare the machine for data learning. And there was a housing data that I found actually on Kaggle. I know Priyansu says we shouldn't look at competitions now, but all I want you to do is just go up to that point where you prepare the data. You can be pretty brave and go to the end, so there's this one, house prices, which is advanced regression challenge, right? And this competition, I put it on the chat, and it has the data. You can see what they were. I'm not asking you to predict. I just want you to explore what features are important, just using the same techniques we've done. And you can see the evaluation. Now, this will start to make sense, right? Subventions are evaluated on the root, RMSE. We know that, we went through that. And where you just say the ID and what was the sale price, and you can look at the description, and this is just to help you with feature engineering. And the data is pretty wide, so it'll be interesting to see how people come up with, like it has all these things and how they wrangle the data based on some of the things we've learned. Okay, so any comments, feedback?
I have a question and then I have a comment.
Mm-hmm.
On the book, when they were showing the median income and on the correlation matrix scatter plot, and then later on diffusion. So the lines. So why are you calling these like data quirks? These are data. Maybe that's important. Why are you trying to take them out? Shouldn't our machine learn that? Why are you calling them uninformative?
They're informative, but your model will overfit. It's going to learn that pattern that you can already see. I mean, and you don't have to remove them. You just have to know that. So this line here is because there's a cap, right? That this is the maximum value of the housing that you can get for 500,000. But they also write about these other. So first, the correlation is strong because you can see the upward trend and the points are not too dispersed. Second, the price cap that we noticed earlier is clearly visible as a horizontal line at 500,000. But this plot reveals other less obvious trend lines, a horizontal line around 450,000 and 350,000, and perhaps one around 280, and a few more. You may want to try removing the corresponding districts to prevent your algorithms from learning to reproduce this pattern, because that's not the pattern we want, right?
Yeah, but it's not what we want. So we want to we want to have a good representative mathematical function of data, not that what we want. So maybe I'm just not understanding this correctly. So those lines are not informative data and are
they
wrong.
are informative, but if you use this, the model will overfit.
All right.
So it's always going to try. It's just like when you use chest X-rays with the pneumonia label, with the ICU label, the model start to figure out, you know, ICU means pneumonia. So it doesn't learn pneumonia.
Yeah, like chest tube means the pneumothorax. Yeah, all right. And then the comment that I had was that the plotting that when they, so it's just basically plotting in 2 dimension, but by that color coding, you can just add another dimension. And it was just so exciting that you can just visualize 3D data in just 2D, and then how you can like there. And then my question was, can we just add more features? Can we just show, can we add another dimensionality to this? And I don't know the answer.
I think we can, but I didn't experiment with it. But it would be great to just go back and try and add more things and see how it does. And you can show us how it works. Okay. Okay. Abby, any comments?
No, I just I've followed whatever you've gone through, all the steps and stuff. I'll try to do it again and see if I able to figure it, like no errors, hopefully. But I'm following through the flow and everything. I'm getting it.
Okay. Chima, very quiet.
Oh, I'm good.
I can hear you. Was this helpful? I know you're a little more.
It was very helpful. It was very, very helpful. Especially the covariance part. We did that, but I didn't quite understand it before. Now I see. It's one thing like to just know how to do the calculator. It's another thing to see, okay, this is why we're calculating.
I mean, I thought really the best thing about this was feature importance. Because if you can figure out your feature importance, you can do anything. You know, and just having this quick way of figuring out feature importance I thought was the best part of this chapter. Toby.
Yeah, and from my end, what I'm still finding confusing is how they were able to calculate per room. Is it per room for the population? Yes. Yeah, and I've never tried something like that before, and I'm wondering the thought process that came into that. What they were thinking exactly.
And this is like domain expertise, right? Is to say maybe what's not important is the total rooms, but the rooms in a household per household. And you see, this is a calculation of this, that the rooms per household, you just have to get the total rooms per the household, right? And so you know in this feature importance, right, you won't know what's important, right? You just have to do these derived variables. One requires you learning, like, what do you think when you sell a house is more important, right? The general knowledge, and then you coming and trying to figure out what those features are important, and then running this correlation to figure out, are they really important or not, you know? And so it's going to be a good exercise, like for you to go through the Kaggle challenge that I showed, where you're going back and you're just saying, what features are important, and we'll all see what people came up with and talk about them, and And that this is how you also start to go through other people's notebooks and start to figure out what features are important. Now in medicine, usually I'll say, oh, because in clinical care, I see this. And this is how I know that this is the important thing, right? So if you hear me talking about COVID, I'll be like, yeah, we know that it affects African Americans because that's what I see. And then you would go back and say, you know, Judy, it doesn't affect African Americans. You know, something like that. Okay. I think Almira's typed something in chat.
Okay, can you please share the link to the Kaggle challenge, the data set?
Okay. Okay. And Ariba shared, oh yeah, there's some good, wow. Okay. Yeah, sorry. I will, thanks Ariba. Thank you so much. We're trying to get this to 1 hour. We're still kind of away, sorry. And then I will share the link to the Kaggle challenge again. I don't know if you're still there, Ariba, but thank you and bye. If you're still there, you can say bye. Sina?
Yeah, thank you so much.
Thanks so much, yeah. Okay. Sina, any comments? Last words?
I mean, it was great. It's kind of a good bunch of went over my head, but explaining those little things and lines about like what they mean in the beginning was super helpful. I need to go through it again. I had the same issues of getting syntax error, so I didn't get to go through it, but it was super helpful to kind of talk through it and kind of go through what they mean in terms of code language.
Make sure
so I appreciated that.
You read the previous chapter, yeah?
Yeah, I skimmed it, but I have to go through it more. Yeah, for sure.
Yeah, and I recorded the presentation for that. Okay.
Oh, perfect.
Pri?
Yeah, I mean, what Almira asked, I have some response to that. Like, Judy, correct me if I'm wrong.
I know that I'm correct, man.
Yeah, our goal is to make a generic model that is able to predict on similar type of data. So there are a lot of features, but every feature is not so important. Like we did in there was a challenge, BGLP challenge. Judy, you must be familiar with that. When we were trying to make a model with transfer learning approach, we found the most important feature to make a generic model to predict on each thing. Though that was not successful, but the point was, suppose you have 10 features, but you know that the 5 features contribute 80% for the prediction of data set or for the 90% of the data set, and the remaining 5% just contribute 10%. So if you are including all the 10 features, your model size is going to increase as well as the complexity of model increases. But if you are including only the 8 features or only the 5 features, your model size is reduced as well as it is almost the same accuracy or even more than that with the full features model, because the complexity is low and the modeling techniques are able to handle well. I guess it's more important when we learn a dimensionality reduction problem. I guess it will be covered later on. So yeah, that's it. Like, we try to reduce the features, not reduce the important features, but reduce all those which are irrelevant or which contribute insignificantly to the data set. So that's the important thing.
Yeah. Yeah, absolutely. Okay, so I would say that go back through this code, come up with your cheat sheet for how you walk through. You can even, like, I'm going to just create the appendix into a notebook and put like basic functions in that I'll be just copying it and starting a new project on. And I'm going to try the housing challenge just to see what features I get. And I think it's gonna be fun. You're not even trying to predict, you're just saying, how do I get here? And then next week we can complete this chapter if it's okay with you. I think this was pretty heavy to try and do within 1 hour, and I'm gonna get better. Like I said, this is like once I'm done with this chapter, someone else is gonna lead the next chapter, not myself. I'll be listening. Okay.
Judy, I have another comment. So actually, it's really good to start one of these Kaggle challenges. But I've seen like you can just start like get involved in a Kaggle challenge, just personally or in a group? Can we just create that? Is that how do you?
Yeah, we should create a group.
Like, how can we do that? I think like most of us have Kaggle, or the ones that don't have them, we can just create Kaggle accounts, and then let's just do that. And I think that's going to be exciting. And then we can just help each other. And then
absolutely.
Is that something that we can do? Like maybe next time we can just. Like,
yes.
oh, all right.
Yes, absolutely. Yeah. Like I said, this is just for collegiality and working together to get better. I mean, this is a fantastic book. It was recommended by Pri when I said we should do the first AI book, and he said, you know, and this, I don't want to talk about his story, but one of our other person we work with, Saptashi, recommended this book to Pri because Pri asked, why are you only trying few times in the Kaggle challenges and getting very good results, right? And it's this critical thinking and process that usually sometimes when you're in the brute force of just making code work and copying other people's code and trying it, it's good for Kaggle and winning, but it doesn't make you understand the fundamentals of machine learning. Even I am learning like quite a bit, and even of how to organize my code, how to, approach problems. And I mean, I think we're going to have a fantastic outcome. It's just stay with the process. Do not give up. And, all of us, we have different skills everywhere. And this is what I should have done this week. When Abby reached out, I should have just said, Chima, help Abby. And so, or Toby help Abby, so that, you're not stuck in this. One thing I didn't create, I created the Slack channel, I just didn't invite people. And actually that's what the recording is. So I'll do that so that we have this asynchronous comments. If you're having a problem, you just post it there and people can help out, Okay?
Perfect.
Awesome. Yeah. Okay, team, have a good long holiday. Be safe. If you're going out partying there in Georgia, please wear a mask. And see you next week.
Hey, see you guys.
See you later. Bye.
Bye.
Bye. Thanks everyone.